Relations and functions. Now let us discuss some definitions about relations and functions. In math, we define relation as any set of ordered pairs xy of real numbers. For example, we have this set denoted by the curly braces. We have a set of numbers 0, 1, 1, 2, 2, 3, 2, 5, and 3, 4. And when we are talking about relations in math, we define two things. We call them the domain and the range. The domain is just the set of all possible values of x. So in our example, our x values, the first element of our ordered pairs are 0, 1, 2, and 3. That's why it's written here as the domain of this relationship is equal to 0, 1, 2, and 3. That is the domain. Now, the range is defined as the set of all values of y. In our example, the y values are 1, 2, 3, 5, and 4, as is written here, 1, 2, 3, 5, and 4. Now, that is a relation or a relationship. Let us define what is a function. A function is also a relation, but it's a special case. There is a special property of functions that makes it different with some relations. But still, it's a relation where no two ordered pair has the same first element. If I go back in this example and we look at the first elements, we can see that this two set of ordered pairs has the same first element. That is, they have both first elements equal to 2. So this is merely a relation. This is a relation, and it means it's not a function. This is not a function. Now, if I remove one of those two, such that the first element of the ordered pair 2 is not repeated, that would be a function. But in this case, it's not. For example, here we have a function. By the way, we write functions in this form like this. F of x means function of x, or sometimes we write this with a different letter like g of x. This is the inputs of the function or the domain. It's a letter, the variable that holds the domain of the function. So let's see. For this one, this is a definition of a function. It's a function with the set 0, 1, set of ordered pairs 0, 1, 1, 2, 2, 3, and so on. Now, this means it's an infinite set of numbers. And sometimes, or most of the times in math, we are dealing with sets with infinite number of elements. If we have an infinite number of ordered pairs, or let's say 100, we don't necessarily have to list them all. We can use a notation similar to this one. We read it as the function of x is the set. This is a set of all values of the ordered pair xy, such that, this is read, the vertical line is read as such that y is equal to x plus 1 and x is an integer. So these two functions are the same. But this one, if we have to write all the numbers, that would be, it would take too long. So we have this kind of notation. And sometimes in math, we simply say that f of x is equal to x plus 1 And this function is equivalent to this too. Uh, it says that I have a function, it takes the input x, this is the input, and the output is equal to x plus 1. So the output is the y values. The output is our y values. This is the output. So we have here, since a function is a relationship, we have a relationship between x and y. X is our independent variable, independent, and y becomes our dependent variable. So that is the relationship between x and y. And as you can see, if y is 3, x can only be 2. No, see that statement. If y is equal to 3, x can only be equal to 2, nothing else in this example. It follows that there are no two ordered pair that has the same first element or the same x's. So these are some basic definitions about relations and functions.